So this is part 2 of the graphing notes. Tried to do this just so that you'd take a little bit of a brain break. Hopefully you hit pause at any point when you needed to previously. Just quickly, I want to kind of point out I'm not going to talk a whole lot about these graphs up above, but I do want to refresh your memory. You should be familiar with what this graph looks like. This is the basic graph, if you notice, of y is equal to 1 over x. So there are those two asymptotes at the x-axis and the y-axis, and that shows origin symmetry, or an odd function that's reflecting over the x-axis and then the y, or vice versa. You won't really see the 1 over x squared graph, but I shared it there just to kind of help you see that that is there, basically. All right, I want to talk to you about the actual process of actually truly graphing these now. There's kind of a special case, and then we'll look at more similar to what you're going to see on the worksheet. If you notice that that the graph that you're asked to graph is basically just a translation of this parent graph of y equals 1 over x, then we want to use what we know about that graph and just do the shifts. So in other words, if you notice, it's saying use the graph of y equals 1 over x to figure out what we're going to do in order to graph this new graph. And I need you to think about what the shifts would be, right? This would be a shift left 2 and then down 1. So if we shift left 2 and down 1, then my new axis, or my new starting place, would be here. And I'm going to kind of draw, because there are asymptotes on that original graph, so I'm going to draw those in. But then to draw in the actual curve, or what the shape of the graph looks like, we just want to go, this number here tells us how we're going to move. That means we're going to go over 1 and up 1, and over 1 and down 1, and we're going to use those points kind of as the guide to help us actually draw in the two branches, or these two curves that you're going to see. Just FYI, if you see one of these graphs and it has a number other than 1, so as an example, if this had said 3 over x plus this x plus 2 minus 1, then instead of going over 1 and up 1, we would go over 1 and up 3, and then over 1 and down 3, and we would use that point kind of as our guide. So I'm going to draw that one in 2. It adjusts the shape of the branch, or the curve, just a little bit. All right. Notice we've got these steps or process. We're not going to actually think through all of that in terms of memorizing step by step what we need to do. We're going to focus on a few of these particular things. So we are going to look for y-intercepts. We do want to consider where x-intercepts are, but our main thing is we're going to focus on finding our vertical asymptotes and our horizontal asymptotes, and we're going to make a list of that. And then we go through the process of this: plot at least one point between and beyond each of those intercepts and vertical asymptotes. So I'm going to show you what I mean by that. Okay, so the process to begin with here on this particular one is we need to decide if there are horizontal asymptotes and vertical asymptotes. So for vertical asymptote, right? For vertical asymptote, we are looking at where the denominator, x minus 2, is equal to 0. So we find that there is a vertical asymptote at x equals 2. Then we're going to figure out our horizontal asymptote. To decide on our horizontal asymptote, in this particular case, if you notice, the degree of each of those terms is the same. And so we write the horizontal asymptote as the ratio of those leading coefficients. So we find that y is equal to 3 is our horizontal asymptote. So I want to go ahead and draw in vertical asymptote at x equals 2. Yes, we need to label these. And horizontal asymptote at y equals 3. And then in this particular case, in order to come up with or figure out what some other points are, how we are going to graph this graph, we want to just plot a couple of points. We want to plot some points that are basically in this interval and figure out whether the graph is above or below that horizontal asymptote. And then we want to figure out what's going on this side. Okay, so let's just plot some points. Let's just kind of do a table of points. I'm actually going to pause this and write out a table of points. I'm just going to pick some x values to plug in so that I can figure out what my corresponding y values are. Okay, so take a minute to pause and look at the x values and plug in those x values and notice how I am getting what those corresponding y values are. That will help you with understanding what this is showing us, that type of thing. So I want to graph these points just to get an idea of what is happening. So I want to graph -2, and I'm not graphing these points from my changed origin. I am graphing these points straight from my real origin. So I'm going left 2 and up. That means I'm going 2 and a little bit more, that 9/4. At -1, I'm at 2. At 0, I'm at 1.5. 1.5. And then at 1, I'm at 0. So I have a couple other little points there I need to kind of clean up a little bit. Sorry about that. Okay, that gives me a pretty good idea of what's going on this side of the graph. And I know, I have not shared this with you yet, but I know that if this part of the graph is going down, then on the opposite side, it has to be going up. So I know eventually this side will go up here. It's just a matter of figuring out where exactly it kind of hits, just to get a better idea. So let's graph some of these points. So 1, 2, 3, 1, 2, 3, 4, 5, 6, and then 5, 4. And that will give me a little bit better idea of kind of the general shape for that particular part of the curve as well. So just so that you know, opposite either side of an asymptote, the direction of the graph will always be opposite directions. So keep that in mind. We will talk more about that, and I will show you a visual of that later. All right, so there's that graph. Let's look at one that's a little bit more complex. This one does not have any holes, but it does have vertical asymptotes and horizontal asymptotes that we're going to deal with. So we're going to deal with, I like to deal with my vertical asymptotes first. So my vertical asymptotes are going to be, I have that factored for you already. So vertical asymptotes at x equals -3 and at x equals 1. For horizontal asymptote, I'm looking at bottom heavy, which means that we are y is equal to 0. So that means we have horizontal asymptote here at y equals 0. And then 1, 2, 3, x equals -3, and x equals 1. Okay, so now in this particular problem, we have 3 different regions that we have to look at or consider. We have this shaded region to the left of the far left asymptote. We need to figure out and consider what's going on in this middle region. It's not very big, but we still have to think about that region. And then this interval over here. So I want to purposefully choose X values that are in each of those intervals so that I can decide, is the graph above the asymptote or below the asymptote, to help me with drawing this. So I'm going to try to color code again, and I'm going to write out a table of values again like I did for this first example. Okay, we're back, and let me show you what I did here. I created a table of values. I showed a little bit more work in terms of how I was coming up with my corresponding Y values on this table than I did on the original problem, but I did color code again for you. So the section here to the left of the left asymptote, I chose X equals -4, and I plugged that in, and I found that I got a positive result. So basically, that's all I need to know that part of this graph goes up and goes like that, approximately. And that's all we're doing, is just kind of a rough sketch. That middle section, if you notice, for those green points that I did, I'm at -2 and then -1 and a little bit more. And then at -1, I'm at -1. And then at 0, I'm at that same point. So it looks like that's the highest point here. And it's going down in both directions like this. And what that tells me is that I know that it has to be up on that other side. It's just a matter of if I need to determine whether or not it's got something special kind of with the shape. But this verifies also, if you notice, these are both positive Y values, so that means they are above this asymptote, and so it's going to go about like this. All right, those are just some rough sketches. That's all we're really going to do. As I said, I will show you a little bit more of visual to kind of help you see or understand the idea that I mentioned to you. If we know this is going up, like here on the right side of that asymptote, then on the left side of that asymptote, I know it has to be going down. So it will be going in opposite directions on either side of an asymptote. You can kind of use that information as well, besides plugging in some points to verify. Hope this helps.